we will now look at cardinality limits. They allow us to express different kinds of relations. We can, for example, express that the relationship is one-to-one or one-to-many, and so on. There's many different notions for cardinality limits. To keep things simple, we will be using the UML notation. For entity relationship diagrams, this is also known as the Martin notation. So we annotate the connections between a relationship set and the participating entity sets using cardinality limits. So n1 ... is a cardinality limit, and it expresses that every entity from the entity set A is related to at least n1 and at most n2 entities from the set B. Likewise, the cardinality limit on the side of A, m1 ... expresses that every entity from the entity set B is related to at least m1 and at most m2 entities from the entity set A. A number of typical constraints are 0.1, expressing that it's related to 0 or 1. 0.*, we write for an arbitrary number. We write 1.1 for precisely 1, at least 1 and at most 1 gives you precisely 1. And 1.* for at least 1. Let's have a look at some examples. We can express a many-to-many relation by annotating both connections with 0.*. This expresses that every A is connected to an arbitrary number of B's, and every B is connected to an arbitrary number of A's. So this is just an arbitrary relation between A and B. If the cardinality limits are not given, then this is the default. So the default is a many-to-many relation. If we annotate both connections by 1.1, we get a one-to-one relation. This means that every A is related to precisely one B, and every B is related to precisely one A. So in a mathematical sense, this gives you a bijection between A and B. And this also means that the entity sets A and B contain the same number of entities. We can express a 0-to-1 to 0-or-1 relation by annotating both connections with 0.1. So by these cardinality limits, we express that every A is related to 0 or 1 B's. So every A is related to at most 1 B. It can be related to 1, like A1. A2 is also related to 1. A3 is related to 0. A4 is related to 1. A5 is related to 1. A6 is related to 0. And likewise, every B is related to at most 1A. So this is a 0-to-1 to 0-or-1 relation. Confusingly, in the literature and on the web, this is often also referred to as a 1-to-1 relation. We can express a one-to-many relation by annotating the one side by 1.1 and the many side by 0.*. So we express that every A is related to an arbitrary amount of B's, and every B is related to precisely 1A. So let's have a look. B1 is related to A2, so precisely 1A. B2 is related to A1, precisely 1A. B3 is related to A1, also precisely 1A, and so on. If we want to express a 0 or 1 to many relation, we annotate the 0 or 1 side with 0.1 and the many side again with 0.*. Now, every A is still related to an arbitrary number of B's, and every B is related to 0 or 1 A's. So every B is related to at most 1A. Let's have a look. B1 is related to 1A, B2 to 0, B3 to 0, B4 to 1, B5 to 1, and so on. So this is a 0 or 1 to many relation. Confusingly, in the literature and on the web, this is often called also a 1 to many relation. We've seen how to express 1 to many relations, and of course we can also express the reverse, a many to 1 relation. We simply annotate the many side by 0 dotted star and the 1 side by 1 dotted 1 as before. It's just mirrored now, and now we express that every A is related to precisely one B, and every B is related to an arbitrary number of A's. So this is just the same as before, the 1 to many, just flipped around. And the same holds for many to 0 or 1, it's just the mirror version of 0 or 1 to many. Let's practice a bit with cardinality limits. First, we want to express that every A is connected to precisely one B. That means we have to annotate the B side with 1 dot dot 1. And we want to express that every B is connected to at most one A. So we annotate the A side with 0 dot dot 1. Next, we want to express that every A is connected to one or more B's. So we annotate the B side with 1 dot dot star. And every B should be connected to at most one A, so we annotate the A side with 0 dot dot 1. Finally, we want to express that every A is connected to one or more B. We again annotate the B side with 1 dot dot star, and every B is connected to precisely one A. So we annotate the A side with 1 dot dot 1. There's many different notations for the cardinalities in entity relationship diagrams. One alternative, for example, is that we use these arrows to express 0 or 1. The engineering style uses such fence to express many, and it uses such a circle to express possibly 0. There's a Chen style, there's a Bachmann style, there's a Martin style, and this style is actually closest to what we are using. If you think of these pairs that is used in the Martin style and you write them with dot dot, then you basically get the style, the UML style that we are using. We speak of a total participation if every entity in the entity set participates in at least one relationship of the relationship set. So for instance, every loan must belong to at least one customer. And this is expressed by this cardinality at least one. So the loan entity set totally participates in the borrower relationship set. Every loan is part of at least one of the relationships. In the literature, one often finds an alternative notation. This is this notation where the totally participating entity set is connected with a double line to the relationship set. The opposite of a total participation is called partial participation, and this means that entities may or may not participate in any relationship of the relationship set.